So here we are going to learn about different things about numpy, like numpy data types, numpy array copy or view, how can we check the shape of numpy objects, how can we reshape it, how can we iterate in a numpy array. So let's start with data types. Okay, so of course in traditional Python we have string, we have integers, float, boolean, even complex. In data types in numpy we have some extra data types over here. We have something about unsigned integer, we have complex float, we have the most important object like date time and time delta, where we can deal with date objects. So mostly in data science, mostly when you are working on any working on any finance project, okay, there you're going to deal with a lot of transaction data. Suppose you're working on a customer analytics project in different companies, you're going to work on the payment data, so everything has date associated with it, like when the customer arrived, on what day, at what time. So in that case, when you will have those kind of data, and when you will be able to of course convert it into a numpy array object, and that time you will be specifically talked about that, okay, in which hours mostly customer arrive. So you can easily make use of the state time object which is inbuilt in numpy, that will give you solution very easily. Okay, so we have string, we have object. So things are not important over here, because of course when you initialize something, numpy tells you which data type it is. So let's start by seeing some traditional way. So I just created a numpy array of numbers and it gave me the data type as int32. So this is like d type, this is inbuilt functionality of numpy. And here in this list I have all the strings. Okay, so it tells you data type of string, which is like here you can see it's u, so it's Unicode string. Now of course we can create arrays by defining data type of our own. Suppose over here, so this is very tricky. So suppose I'm giving here numbers, and of course traditionally if I look at the data type, it's integer, but we can forcibly assign that this is s, and it becomes like a string data type. So at many of the times what happen is you have to treat numbers as object or strings, because like most, like all the machine learning algorithms nearly cannot deal with sometimes cannot deal with numbers. They wanted it to get converted into a string. Suppose you want to add a number to a string, and you are working on a series of list or like a numpy array, so you want to add those chunk of things in a string. So in that case, easy to like convert it the numbers into a string, and it becomes easy. Now suppose I want to convert data type on existing array. So many of the times there will be a scenario that when you are getting data from any database or any cloud, your data type may not be correct always. Okay, sometimes they will treat numbers as numbers, like they will treat numbers as string, and then you have to convert that string to numbers. So there we have this command which numpy gives us as type. Suppose here I have a floating numbers, okay, and we don't want to consider these floating, we want to get the nearest integer. We can just convert it into I, like we can use this I over here, and see, you can see the new array data type, which is this one, which becomes 1 2 3, like 1.1 becomes 4, 1, 2.1 becomes 2, 3.1 becomes 3, and I can see the data type which is int32. So this is very important, this line. Okay, now so I can use I can use int. So you can go through documentation, but most of the fundamental things have been given here. Like you can see over here that data type can be specified using a string, like f for float, I for integer, or you can use data type directly like float for float, int for integer. So here I done the same thing, instead of I use int. now now let's see about what is array, copy and view. So most of the times we want to create a copy of an numpy array or a list. Like you are working on a list and you want to like perform two different operations on the same list. So you kind of make a copy of a list and you do something else on the second list and you do something else on the first list, but both lists are same. So this numpy array copy gives you a facility where when you make a copy, suppose here I made a copy of this array, so this is ARR, and I got X. So I made changes to my first array and nothing happened to X because it was a all new element X, like all new list X, which is like array X. And I made changes in my original array and my original array changed, but my new array has not changed. Like here I change 1 to 42 and you can see the change here, but in the new array the change has not happened. Now suppose I'm doing a view, okay, and here I'm making change, like I did a view and I got new array X. Here I made a change, of course my array changed, like my one became 442, but my X also changed. So that's the difference between copy and view. Now let's check the shape. So shape is of course very important, like when you're working with data frames, like when you're working with rows and columns. So a single command can tell you that okay, how many rows are there, how many columns are there. Similarly here you can see that we have, like you can see this, like shape of an array is the number of elements in each dimensions. Okay, now each dimension has 4 elements, like the first dimension has 4 elements, the second has 4 elements. So you can see we have 2 dimensions, 4 elements. Now so of course this is a 2D array. Suppose now you have given an option about, like given a question around that create an array with 5 dimensions and with this end command with a vector with values 1 2 3 4. Now and of course verify that last dimension has value 4. So I just did 1 2 3 4 and I just passed 5. Now you can see the shape, it's like 1 1 1 1 4. You can even count the brackets, a 1 2 3 4 5. So I told you in the last video that count number of brackets. So there is just 4 element, which is this 4, and there's just 1 dimensions, 1 1 1 1. Now suppose we want to reshape an array. Okay, I just want to convert an 1D array to 2D array. Okay, so I have this 1D array of 12 elements. So what I can do is I can, so 12 elements, so it's like 4 is to 3. So we can even do 3 4. So we have 4 dimensions and each dimension with 3 elements. Now suppose I want to change into 1D to 2D. So you can see I have like 2 dimensions, then I have 3 different arrays like this, like 3 different arrays over here too, and 2 elements in each array finally, 2 2 2 and similarly 2 2 2. And like I tried converting 1D to a 2D with 8 elements and I was not successful. Like I want to convert 8 element with 3 element each, so this was not possible. Now suppose we want to flatten the array, like you can see there are a lot of, it's like 2D dimension. You can just do reshape -1 and the entire thing will be converted into a list or like a 1D array, a 1D numpy array. Now this is very important, iterating. So of course we use for loops, while loop in list in traditional Python to iterate over all the elements. The same thing can be done here. So I have this 1D array and I can just loop around it for x and add print x, so I get 1 2 3. Similarly what we do in 2D array, so Now of course, like 4x in add, print x. So I get 1 2 3 4 5 6. So it consider this as the first dimension, this as the second dimension. So it prints entirely this. Okay, now we want to iterate on each scalar element of the 2D array. Like we want 1 2 3 4 5 6 individually. What we do, we do 4x in add, then 4y in x. So you can see this x is kind of a list. So it gives you 1 2 3 entirely. So when I'm doing 4x in add, I have this 1 2 3 here. Now again I'm iterating over this. I am getting 1 2 3, then again 4 5 6. Then same thing I do here. When I do I just want, so we again have like 2 dimension. So this is like a 3D array. So you have 3 square brackets. So it gives you first element which has 1 2 3 4 5 6, then it has, and again second element which has 7 8 9 10 11 12. Now again I want to iterate down to the scalars. I do this like a 3 loop. But don't you think this is very like time consuming? How much can you do, like how much for loop you can add? And of course remember this, that for loop is always not recommended in code. Like how much it's looking like code is already increasing, and you are just going through a array. So numpy gives you its own inbuilt functions to deal with this, to deal with iteration, which is this command nditer. Okay, now suppose I have this 3D array with me. Okay, this automatically flattens the array, and then you can just get each element one by one. Now here, if we want to iterate with different step size, like we want 1 3 5 7, so same thing. So you are fixing like 2 rows and 2 columns. So we can do this with by like we have to, like here it's like we have to skip one element. So this is fundamental command, and this is something. Okay, so here you can see that I'm selecting both the dimension. Okay, now I want to select every element, like every scalar element by skipping one element. So I can just get 1 3 5 and 7.